In this video, we will demonstrate how to program a KUKA robot using different motions and logic controls. First, a new file named Component Contour 1 is created. Open the file and ready to edit our program. The main objective of the program is to guide the TCP to follow the contour provided on the table. Two coordinate systems will be used, which are the axis-specific motion and world coordinate system. Axis-specific motion will control the wrist of robot, whereas world coordinate system will move the robot linearly in X, Y and Z directions. Before we start, make sure that the TCP is at its neutral position by adjusting axis 6. Move the TCP to the starting position by adjusting X, Y and Z values in world coordinate system. It is important to keep the TCP a distance away from the drawing table. Move the TCP to desired endpoint, then press motion. Select PTP that represents point-to-point motion. PTP motion will allow the robot to move from the previous home position to the current point in the fastest path. After that, a linear motion is inserted to move the robot in straight line. To do this, move the TCP to the desired endpoint, then press motion. Choose Lin from the option, then press Command OK. Next, we want the robot to move in a circular path. The programming sequence is different compared to PTP and linear motion. Motion is selected before we set up the points. Choose CIRC from the option. Instead of 1 point, we need to teach 2 points when using circular motion. They are the auxiliary point and end point. After moving to the auxiliary point, press Set Auxiliary Point. At the end point, press Set End Point to complete the motion. The procedure is repeated using circular and linear motions to travel along the contours. Testing of program. In order to verify the motion, the program is run in manual reduced velocity, which is the T1 mode. The speed can be set to 100% because of lower mode speed. Turn the mode selection key to bottom left to select T2 mode. The purpose of T2 mode is to execute the program in higher velocity. Unlike T1 mode, it is safer to run the program in the range of 30 to 50% of maximum velocity to protect the tools. Next, the program is run using automatic mode. In this mode, the drives on button must first be pressed. After that, you will notice that the icon has turned green. The program will continue automatically after pressing the start button. The program is duplicated and a new file named Control Contour 1, 2 is created. In this program, we want the TCP to follow a curved path in between the linear lines of point 14 and point 15. This can be done by approximate positioning. The meaning of approximate positioning is that the motion does not stop exactly at the programmed position. First, move the cursor to line 14, edit it by pressing Change, then select CONT. This indicates that approximate positioning is on. Next, move to the motion parameter, and set the approximation to 100 mm. This is the distance from the end point where we want to start approximate positioning. Start the program in T1 mode and observe the changes. Repeat the process in T2 mode. Repeat the process in automatic mode. The program is duplicated and a new file named Control Contour 1, 2, 3 is created. For the robot to stop its motion for a period of time, the function wait can be used. To insert this function, press Command from the menu bar, then select Wait from the logic option. Then, enter the wait time. In this program, we select 10 seconds of wait time. It indicates that the robot will stop for 10 seconds before executing the next line. A wait for function is needed if execution is only started after turning on certain input. From command logic, select Wait for and choose Input 13. The robot will stop its motion and wait for signal from Input 13. After switching on Input 13, the program continues. Next, the SIN-out function is implemented to trigger a switching action relative to the start or end point of a motion block. To start with, select SIN-out from Out option in command logic. The number 15 represents the number of output device. In this case, 15 is the number of LED indicator. Change state to true to light up the LED once SIN-out is executed. Next, out of the three options, Start, End, and Path, Start will trigger the action once the robot reaches point 7. If End is chosen, the action will carry out after it reaches the home position. In Path selection, it helps to specify the distance of switching action. Delay time can be set in positive or negative integers to delay or bring forward the motion. One more line of SIN-out must be added in order to turn off the LED. Now, state is changed to false to complete the action. Run the program in auto mode.